We're going to continue now with what we started last time when we were talking about variables, which is something that we've mentioned but haven't really explained or described. So we're going to start up Visual Studio Code again, and I'm still in the project from last time. Now, one thing to be aware of is when VS Code loads up, you might see this little spinner down here. When this icon stops spinning is when you'll get your little run and debug buttons up here. So down here it says Java, and this Java SE11 was that spinning wheel. When it finished spinning, this is what we got. So one thing to talk about is this idea of a variable. So the first thing to understand, and I'm going to kind of draw out a comment here to kind of try to visualize this. You can think about a computer as having memory. And a computer's memory is a grid system. All the grid pieces are about the same size. So let's see. This one needs one more. There we go. And they're all laid out nice and consistently. And each of these little blocks can hold data. And the kind of data it can hold changes. Some data only takes up one block, some data takes up 2 blocks, some data takes up 4 blocks, some takes up 8 blocks, so on and so forth. And depending on what kind of data you're working with is going to affect how many blocks that data takes up. When we create a variable, we're actually setting aside one or more of these blocks and giving it a name. So one type of data we can work with is called an int. Int in Java is short for integer. As a note, and an integer, remember, is just any whole number. So it could be 0, 1, 2, 100, 1,000,000, or it could be a negative number, -1, -2, -100, -1,000,000. But any of these whole numbers, including 0, positive or negative, just like you would have seen in math class. So in computer science, an integer is the same thing as it is in math. And so when we say int right here, we're saying I'm going to create a variable that's going to hold some data, and the data it's going to hold is going to be an integer. Then we have to give it a name, and I'm going to name this my integer. And that just means I have set aside some of these blocks, and instead of having to know where in memory those blocks are, I can just say I'm going to call those blocks my integer. So notice we're not actually saying where these blocks are. Java is going to get these blocks for us automatically and give it this name, so that when we want to use those same blocks of data later, we don't have to know where they are, we just have to know what they're called. And so I'm going to say that this, let's assume this is the block we got. And if it is the block we got, great. If not, it doesn't matter. This is just a visual representation. I'm going to stick a number in there, and I'm going to stick in the number 7. So here's my block, and I'm going to put the number 7 in there. So whenever I say my integer, I'm talking about that block. Right now it has 7 in it, and there's an equal sign here. One thing to be aware of in Java, and in most programming languages, when you see one equal sign, don't read it as equals. Read it as gets. So what we're saying is the block with name my integer gets the value 7. And that's important because when we see equals, we tend to think that my integer is the same as 7. But remember, my integer is not the number 7. It's just where in the computer's memory did we stick some data. So that on this next line, I can say my integer equal 9, but remember we read that as gets. So my integer gets 9. So we change it from 7 to 9. The only other, and we'll see how this works kind of mechanically in a minute, but a couple more things to note. I have semicolons on both of these lines. In Java, when you want to finish a thought, when you want to finish a line of code, it's called a statement. And statements have to end with semicolons. Now notice we have these curly braces, but no semicolon. Here we have these curly braces, but no semicolon. That's because a method isn't a statement. It's a block of code. It's a way of organizing your code. Lines that end in semicolons are executable code. It's things that run. And this kind of takes some practice getting used to, but once you're familiar with it, once you've practiced with it, it kind of becomes obvious when you need a semicolon and when you don't. So that's something important to note here. And then notice that we didn't have the word int on this line. That's because on this line, we are doing what's called declaration. And when you declare a variable, you have to say, what is the variable's name and what kind of data will it hold? And you only have to do that one time for each variable. So on this line, I don't need to say that it's an int again because I've already said I'm going to create a variable whose name is my integer that's going to hold an int data type. So on line 23 here, we don't need to say what kind it is because we declared it to be of a certain kind, which means it will always be of that kind. Now I'm going to delete this line 23 and go back here to line 10, put my 7 back. In Java, if we want to know what data we put in something into a variable, if we want to be able to read that data, we can print it out. And the most common way we'll do that is with system.out.println. And that line ends with a semicolon. This is a special method in Java that lets you print data. And it's called println because it prints a new line of data. So one concept in programming is that code executes sequentially, which means first I create a variable called my integer of type int that holds the number 7. Then I print some data. Now the data I want to print is my integer. So I'm going to put my integer in these parentheses here. So on line 21, the first thing that's going to happen, because remember we're in the main method, this is where the program starts. On line 21, we put 7 in my integer. On line 22, we print the value in my integer. So I'm going to run that. We're going to build, run, and we see here 7. Now if I go to line 23 and I say my integer gets 9, that block of memory changes from 7 to 9. I'll save that. And then I'm going to add another line, system.out.println my integer. And when I run this, compile run, so we'll see 7, then 9. So walking through the program, first we created an integer with the value 7, then we printed that value, then we gave it a new value of 9, and then we printed it again. And this is going to be true for pretty much any variable of any type. This isn't going to change. Now, earlier we mentioned that when you declare a variable that holds a data type, and different data types take up different spaces of memory. The example up here isn't quite right because integers don't take up one block of data. They actually take up 4 blocks of data. So this 1, 2, 3, 4, 1, 2, 3, 4. This is where my integer can be stored. And the more spaces it takes up, the bigger the number it can hold is. We'll talk more about the different types, but that's kind of the first step to know about, is that one integer takes up 4 blocks. Now, the other data types are floats, and we'll call this my float. And a float is like an integer. It can hold a whole number 5, it can hold a whole number 0, or it can hold a decimal number like 0.1. And it doesn't like this notation. So what we're going to do is, instead of talking about floats, we're going to talk about doubles. I'm going to call it my double. And now Java's happy about that. Floats and doubles both hold decimal numbers, but doubles are Java's default for decimal numbers. And so we'll stick with doubles for now. Now it can hold a decimal number like 0.1 or negative 0.1 or negative 10.1 or positive 10.1. It's going to hold a decimal number. And again, remember, those include numbers without decimals. This is perfectly legal in Java. So a common decimal number is 3.14. And if I want to make sure I'm doing that right, I can do system.out.println my double. And like we saw before, I can change that, and let's make it another number like negative 1.5. And I'll print that out again. Println my double. Okay, so I'm going to run this code. And now notice we still get the 7 and 9 print out first, because the lines where we did an integer came first. But then we get our lines for the double. So if I were to add a comment here, I would say that double is what's called a floating point number. And floating point is related to this idea of decimal numbers or real numbers. It's not quite the same, because there are other ways to represent decimal numbers, but we won't get too deep into the weeds on that right now. So you have ints and doubles. You also have this variable idea called a boolean. And we're not going to look too much at booleans right now, but they're super important and they're going to show up again and again. A boolean is a very simple value. It only has 2 values it can take. It can take either true, and we'll see that printed out, and if one value is true, the other value it can take is false. My boolean. So when you see boolean, you need to think true or false value. Some languages just call these bools. Java calls them booleans. But if we run this code, we can see our int value changing, our double value changing, and our boolean value changing. So at this point, we've actually created 1, 2, 3 different variables. So we've allocated, set aside some blocks of memory for an integer, for a double, and for a boolean. So those are kind of your 3 common basic data types. There are other types of integers besides just int. There are other types of doubles than just, or other types of floating point numbers besides just double. There's only one kind of boolean, more or less. We'll talk more about the different quote-unquote types of booleans, but really it's just a boolean. And then the 4th type of data you might deal with a lot is what's called a string. When you see a string, you just want to think text. And a string is a much more complicated piece of data. Integers, ints, floating point numbers, doubles, and boolean types, booleans, are what we would call primitive data types. They are very simple and they are very predictable in how they occupy memory. Strings are objects. And we're going to talk a lot more about objects later on in the lessons, but objects are much more complicated data types. They have a structure to them. They have more to them than just how much space do they take up. But all of that is kind of buried deep into the Java details of a string. We can work with it as if it were a simple data type, which is going to be true for any kind of data in Java, that no matter how complicated the data actually is, we can still work with it as if it were a simple data type. So we declare it the same way. It is a string, my string, and we can give it a value. This is some text. Now notice that strings start and end with double quotes, which means you can't actually put double quotes inside them without a backslash to say, hey, this isn't the end of the string, this is more of the string. But we'll try to ignore that for right now. And I can print it out all the same. System.out.println my string, and I can even give it a new value and say this is some different text. And I can run system.out.println my string. And if I run this code, my integers up here, my floating point numbers up here, my booleans up here, and then my string is here. So when you first get started out with Java, these are probably the 4 data types you're going to work the most with, because they're the most common ones you'll run into and the ones you'll see the most. So that's kind of all we need to say about variables right now, just kind of at a surface level. Remember, when you create a variable, you need to tell it the type and name, and you can give it a value. You should always give your variables values when you create them. And doing this, declaring a variable, is giving a name to a chunk of memory. Different types of variables take up different chunks of memory. An integer takes up 4 blocks. A double, I believe, takes up 8 blocks. A boolean should only take up 1 block, and a string, again, is more complicated, so we can't really predict how many blocks it will take up. The equal sign doesn't mean that the variable is equal to that value. It means the variable has that value or is being given that value. So here I'm giving the variable the value 7. Here I am giving the variable the value 9, and that changes the value. Same thing for the double here, and the boolean here, and even the string here. A couple more things to talk about. We've been using system.out.println. There is also what's called system.out.print, which looks very similar, right? And it's going to work the same. The only difference between these two is that println puts all the text on the line and then creates a new line. Print would just keep printing to the same line over and over without a new line happening. So if I were to do this line twice, and I were to run the code, here you can see this is where I called just print, because the text got printed and then I kept going on the same line. Generally, you'll probably want to avoid that and prefer println for right now, but it can get more complicated later. The other thing that you might want to think about is something called a constant. Now, a constant in programming means what it does in math. Constants do not change. Now, a good example of a constant is pi. So remember, we said that to do a decimal number, it's going to be a double, and it's going to be pi. So I'm just going to name my variable pi. And I'm going to give it the value 3.14159, which is not exactly pi, but it's good enough. Now the problem with pi is that I could do something like this on the next line. And the issue here is that, well, pi is always 3.14159. It's not 3. But because it's a variable, right, I can change the value. I can say, okay, no, I want pi to have this value now, which is not good for a constant. Fortunately, Java has a tool for that, and all we have to do is put the word final before the word double. And this works for any kind of variable, doubles, ints, booleans, strings, to an extent. Strings behave a little differently, so it may not be exactly what you would expect. We'll talk about that later. But what final does, it says, okay, it means take this variable and make it unchangeable. So when I do this on the next line, I get a red squiggle under here. I hover over and it says the final local variable pi cannot be assigned. So that means I can't change it. But I can still print it, no problem. It's going to behave exactly like I would expect. So when I run this code, there's pi. Oop, no, that line. And again, this works for doubles, this works for ints, this works for booleans, doesn't matter, for the printer data types, and for object data types like strings, it's going to behave somewhat the same way. It means I cannot use the equal sign again to change the value. So that's something to keep in mind. The only other thing to talk about with variables is how you name them. I mentioned last time we talked about comments that we want to avoid comments when we don't have to use them. And that's because comments can make the code look a little clunky. It's important to give your variables meaningful names. So in all of these, I gave them pretty basic names like my integer, my double. But let's say I was writing a program that kept track of a person's age. I would create an integer and I would name it age and set it equal to a person's age, whether it be 7 or 17 or 107. All right, I can keep track of it that way, 30. Whatever you name your variable needs to be indicative of what does it represent. Now, if you want to be a little more specific, a little more declarative, and you can say, okay, I want to keep track of my age. The way that we do that is we write out both words, no spaces. The first letter is always lowercase, and the whole word is lowercase. So my is lowercase. Then each word after that gets the first letter capitalized, and then the rest of the word is lowercase. So this is my age. Or if you were keeping track of your brother's age, you could say brother age. Or if you were keeping track of your grandmother's sister's age, the first word does not get capitalized, but then the first letter of each word after that gets capitalized. And we call that camel case because the capital letter to start each word after the first word looks kind of like the humps of a camel. The only thing that I've done wrong up here, and I say wrong kind of in quotes because it's not bad, it's just not the ideal practice, is that anytime you have a constant, a final, it's good to just go ahead and name it in all caps when you can. So instead of lowercase pi, it should be capital Pi, and then you have to fix it everywhere that it shows up. So that's kind of the introduction to variables, and there's a lot more to do with variables, but it's important that you get comfortable creating new variables, changing their values, printing their values to the screen, and you can do a lot more with println, which we'll probably look at next time, but we want to kind of keep it simple for now. So a good exercise you can kind of go through here is try to declare more variables, try to change their values, and print out the results as you change them and see if they behave as you expect. So next time we'll probably look at some more with println and what you can do with it. And we'll also see how we can start operating with these variables, because just putting data into variables is useful, but we'll want to do some work with them and see what we can do with them. So that's where we'll stop for now on the variables lesson.